All right, everybody. Hello, and welcome to this episode of Boss Cranky's Coding Camp. I am the one and only Boss Cranky, and I'll be your host as usual. Today, we're going to talk about extension method. Oh my gosh, man, what happened to your hair?
Oh, man, I was getting my roots touched up and fell asleep in the chair.
Well, okay, Gandalf, we're going to go ahead and get started anyhow. I'm sure it'll be fine. Like I was saying, today we're going to talk about extension methods in .NET using C# in particular. We have a couple of real basic examples that we're going to use today. But first, let's talk about what extension methods are. Extension methods are a way for you to extend the behavior of pre-existing classes without actually having access to the class. That's not entirely true, but it sure looks that way, right? It feels that way at runtime. It looks like it. And it's just sort of a neat feature. It's kind of a little bit of syntactic sugar that you can use to make your programs a little easier to understand. I'm going to post a link below to Microsoft's explanation about what extension methods are. They'll do a whole lot better job. They have an entire staff of people to do things like this. So we're just going to dive right in. We're going to start with a real basic example that works on collections. You'll notice a couple of things here. To create an extension method, the method itself must be declared as static within a static class. And you may be looking at this syntax right here that's a little unusual. Now, I'm betting that there are some C++ people out there that will look back at this and say, hey, this looks kind of familiar. We may not have gotten there yet, but I think we will. This basically designates this method as an extension method, special flag to the compiler and all that jazz. Again, my C++ people out there will say, this looks awful familiar, especially when we look at how this is used. We'll take a quick look here at this method just to see what it does, ignoring this particular syntax for the moment. So what we're doing here is we have a method called hasEntries. We can read the XML doc and see that, if we've got anything in our collection, we get a true back, otherwise false. And this method is null parameter safe. That is, we won't raise a null pointer exception if we get a null in. Some of you are thinking, we can just specify in our method contract that if you pass a null, we'll probably raise a null pointer exception. And that would be fine, except for the fact that somebody is going to pass a null and then blame you.
Said a little bit differently, some a-hole is going to pass you a null parameter, and things are going to start blowing up in prod, and everybody's going to blame you. You don't want that. I don't want that. That's just the way it'll be.
We've taken care of that with this right here. This little bit of logic right here says, if you pass us a null, I don't care. I'm going to treat a null as not a particularly special case. If the supplied instance is null, you must not have any entries. Otherwise, I'm going to check and see if you got anything. So let's look at how this is used. Go to this first reference in our tests. Just as an aside, when I'm creating unit tests, I kind of like to have one test case that is all true or all positive, if you will, and then an additional test case that is all negative. Test the one happy path, test the unhappy path. That's not all you should be including, but it is sort of what we're working with here. So in use, you can see here we're defining a dictionary with no entries. We're adding an entry, and then we're asking, does this thing have entries? And I'm asserting here that it must, right, for us to do anything. To demonstrate that polymorphism actually works, we create an array list, we add a couple of elements, call the method again, we define a list here, and we store it in an iCollection reference, and then call the method again. All right, so I'm going to come over to our test explorer. So let's just run this. Hooray, it worked in 44 milliseconds. Awesome. So I know what you're thinking. That's not really that interesting. You're kind of boring us here. No, that's okay, because it gets better.
Listen, I wouldn't use cheeky as an actual variable name in a prod program, but I do take liberties with test cases. That's just how it is. That shouldn't present a problem to you. If it does, you're focusing on the wrong things. Also, maybe you ought to reach around behind you and pull that stick out of your ass.
So that was the happy path. Let's take a look at the unhappy path real quick. So you can see here, we're basically saying define a dictionary with no elements, define an array list with no elements. Oh, and what's this then? Here's a special condition apparently. So let's take a look at that, see what that's all about. You can guess that these are going to return false, but what's going on down here? Oh, well, let's see here. All right, so we're defining a collection reference. We're initializing it to null explicitly. We're calling the hasEntry methods of this. even with this being a nullable reference, if we tried to call a conventional instance method, this would give us a null pointer exception. So let's take a little quick peek at this one, run it, and see if it blows up on us. Some of y'all are probably still thinking, well, it's going to blow up. Others may be thinking, gosh, I don't know. Let's see what happens. And it ran without problem, including this test condition here. So that's kind of cool. You can actually have a null reference and sort of call a method on it. And it's all because we're doing defensive programming. Defensive programming says, don't trust anybody. We don't want to assume anything. Even though we broadcast in our contract the conditions that we may have said, don't assume that everybody's always going to honor it, either by hook or by crook, like I've said before. Either by accident or intent, you might end up with a null reference here. So yeah, this particular method doesn't save us a lot. It's kind of handy, really, if nothing else. We don't have to constantly check our collection references for both of these conditions. We can just say as entries. And you'll note back here in the unit tests that we are using our extension methods. That is a standard .NET using statement. We have our methods in a DLL. It's all very vanilla stuff we should be used to. So that's our first test case. Our first extension method. Our second extension method looks like this. Let's take a look at the XML doc real quick here and see if it tells us anything. Basically, what we're kind of could surmise from this description is, given a particular string, does it contain something that means true? And you'll note that even in the remarks there, we're saying, in this implementation, we are assuming that anything that doesn't look like true is false. That is to say, you won't get a true, false, or null out of this. You'll get a true or a false. That should be enough for most people's conditions. I use this method a lot when I'm reading things from a config file or from maybe a settings table or something along those lines, because who knows what people are going to include in their configs. Now let's take a look at what we've got here as implementation. All right, so this is a little bit more code than we saw in the previous example, but not too much. We are checking to see if the parameter is null or empty. Again, that's just a little defensive programming, that we're implementing. If it is null or empty, then it must not contain anything that represents true. So we just sort of fall through. If it does have stuff in it, then we go ahead and take the leading and trailing spaces off. That's optional. You might want to enforce the lack of spaces. It's up to you. And then we set our return value based on the contents of the string. And you'll see here that I've got a bunch of hard-coded stuff, true, T, 1, Y, yes. And we're doing string comparisons on all of that after we've done the trimming to say, basically this represents the various ways that I've seen true represented in a string form.
Some of y'all are saying, look, this method only has one return statement. You're right. Congratulations. I could probably add a return there on line 33, but I've been bit way too many times by some 400-line function that just has a random return scattered throughout, and bam!
A couple of things you consider here. One is, you'll note that I have true as my first condition, and then T, and then 1. These are all ORs. So the moment we find a match, we're going to be done. You may wish to reorder this sequence of checks, right? You may wish to say, well, my most common condition is that somebody provides a Y or a 1. Well, go ahead and move that to the beginning so you don't have to do the string comparison over and over. Yeah, string comparison by itself isn't a hugely expensive operation, but if you were in a situation where maybe you're calling this, in a tight loop and wanting to execute this hundreds of thousands of times, then maybe it would make a difference, right? So kind of optimize for your case. The second consideration is that this is English. True, yes, Y, all of those are English words. So if you have a case where English values aren't what you're looking at, you'd want to change this. Now you could make this read from a resource file. You could make it read from a config, from a database, whatever you want to do. I kept it simple here because while I do hate hard coding, in this particular example, I've isolated it all to one location. So it's not too bad in my opinion, especially not for the educational purposes that we're here for. So let's go take a look at how this is used. And again, it's just like any other method, right? We define a variable, we give it a value, and then we check it. In this case, we're doing the negative testing first. So monkey will never represent true. N will never represent true. Same thing with maybe. We're playing a little bit of games with the English language there. And again, we've got this same condition where we set the value to null, and then we call a method on a null reference. Ooh, neat. Now, by now, you all realize this is going to work, but let's run it just for the sake of running it. And sure enough, it ran. Now, how cool is it that you can actually call a method of a null reference? I don't know, man. That's just That's just bonkers to me. We come down here and we take a look at our positive test case. Now, you may have noticed in the implementation that I said ignore case in the string comparisons. So little y, capital E, lowercase s, that ought to work. I'm also stripping the trailing and leading spaces, so that T should work. They're on line 56, as should the 1 on line 66. So if we run this one, sure enough, everything passed, which is cool. All right, so that was a very basic introduction to extension methods in .NET. You can make them as complicated as you want. I tend to use extension methods where I do the same thing kind of over and over, like this. You could copy and paste this everywhere. That's just tacky, though. To me, that is difficult to maintain. And if you have a bug, you have a bunch of touch points where you have to make fixes, and that's no good. I tend to use extension methods when I'm doing the same thing over and over, and I really only want to implement it one time, which is the way we ought to be doing all of our development, right? Every major language out there supports functions of one form or another. We call them methods when they're class related or object related, but they're functions in other languages like C. That's all I have for today. I'm going to include a link to the Microsoft page on extension methods in the description, as well as a link to the repo. Pull down the code, take a look, see if it works for you, and I will talk to you all later. So long, everybody.
What? Oh, I'm good. I don't always have to bust out the chair.